Okay, so yesterday I gave you guys an assignment. Sorry, it's not an assignment. It was lab. Yesterday was Monday, and it was experiment lab 2, right? And lab 2 is on free fall and also on projectile. And dalam the experiment there was ada macam kena ada marble, guli kaca kan? Marble ball. Apa entah nama dia? Okay, and then ada getah pipe which you would use for your projectile motion. And saya tak dapat respon lagi pasal ni sebab semua orang tengah busy pasal audit. So I'll let you guys know. And I'm extending it by another week. So don't worry about that. I'm sure you will have the time to do it lah. Okay, lagipun eksperimen senang je. The free fall is just like tossing the thing and then recording the time that it takes to fall down from a height. Ada banyak heights kan, and then you just drop it and record the time, and from there you get the gravity and so on. And then for the projectile motion, letak guli dalam dia punya pipe, let it go, and then it will go off into a projectile motion that we will learn later today. So that's going to be exciting. So you guys, after you guys learn, you can apply it in your lab. So I think it's going to be fun. And I have found, I received a video from one of the ex-students as per yang dah buat experiment too. So I will share that with you guys. So you guys have a rough idea on what to do and how to do the mini project, and how to do the video lab. So the entire class is divided into 2 groups. One group, the first half will be doing a video on lab 2, and the second half will be doing a video on lab 4. The video is not to be exceeded 3 minutes. It should be short. It should be straightforward. Your discussion should not be in the video. Your discussion should be on the worksheet. Macam biasa yang kita buat in lab 1 tu. Your discussion was on the worksheet. But dalam video tu, you guys have to like show us how to do the experiment. Like tell us what are the apparatus or what are the materials that you need, and then proceed to tell us how you should do the experiment. Kiranya macam setting up the experiment and doing it. Betul? The results tu boleh tunjuklah how you measure the results, but the discussion of the results should be on your worksheet. So it's just like a physical, you guys like experimenting. Buat benda tu je lah. There's no like theory sangat lah. Okay. So it should be a fun lab lah and easy. Should be. And you can be creative with it. Okay, so nanti kita akan buat deadline untuk tu. Not yet because lab tu kita tak tahu lagi macam mana nasib kita. Let's wait for the bosses to get done with audit, and then kita boleh clarify dengan diorang if you guys can use whatever material that you have, or we providing them to you. So at this point I don't know yet, and kelas lain pun tak start lagi lab tu. So you guys are safe. Okay. Alright, so we have done example 2.2. So this was on linear kinematics. So I hope everyone has remembered the 4 equations. It's V equals to U plus AT, S equals to 1 over 2 U plus V times T, S equals to UT plus 1 over 2 AT squared, and the last one, V squared equals to U squared plus 2 AS. Kena hafal semua ni, equation ni kena hafal. You will use it for linear kinematics problem, for free fall, and also for projectile, and also for I think semester tu pun ada pakai sikit this linear kinematics. Alright. Okay, so this is another example. Instead of doing a recap, I want to do this example terus. That's your recap lah. Okay, so let's do this one. So a car starts from rest. Remember, if I told you it starts from rest, means that your u is equal to 0. So you have u, which is the initial velocity, and also your final velocity, and travels for 5 seconds. So your t is 5. With a uniform acceleration, remember our linear kinematics punya equation is entirely using uniform acceleration. Tak ada instantaneous acceleration. So when they say uniform acceleration in the problem or in the question, don't panic lah tiba-tiba nak kena cari average acceleration macam mana ni semua. No, the equation is already using uniform acceleration. So just use the linear kinematic as it is. Okay. acceleration of positive 1.5 meter per second squared. So that is your acceleration is a positive 1.5 meter per second squared. So can anyone tell me what does a positive acceleration mean? What does it mean? Ingat lagi tak?
The speed is increasing.
The speed is increasing. The speed is increasing, betul. What if my velocity is negative but my acceleration is positive? What if my v is negative and my acceleration is positive? What happens to the speed? Is it increasing or decreasing? Dun dun dun. Forgot. Okay, so remember, kalau sign sama, yes, speed increasing. Your first answer was correct. But if they have different signs, walaupun acceleration is positive, then it maksudnya the magnitude is increasing, yes. When magnitude is increasing, but the sign is negative. So bila kita punya macam nak cakap 50 meter per second is less than 20 minus 20 meter per second. So walaupun magnitude dia naik, we consider this slowing, how do I say this nicely? Kejap. Okay, kita buatlah example dulu. Susah nak cerita macam ni. So dia kena sign sama for speed to be increasing. Okay, so that is my point here. So that is something that you need to remember. Sign kena sama. So in this case, positive with positive, yes, speed increasing. Kalau sign tak sama, then speed is decreasing. Okay, a car starts from rest. Okay, blah blah. The driver then applies the brakes, causing a uniform acceleration of minus 2 meter per second squared. So mula-mula they start with u1 equals to 0. The first acceleration is positive 1.5 and then the time is 5 and we don't know how far did the car travel during this 5 seconds. Kita tak tahu. Yang kita tahu acceleration dia, time dia and the initial velocity. And then at some point here, the driver applies the brakes and dia tekan brake tu selama 3 seconds. For 3 seconds. And because dia tekan brake, maksudnya speed dia berkurang. So the car is slowing down, right? This part, it is speeding up. Okay, now let's see. Tadi I told you if the sign is opposite, you are going this way, your V should be positive, right? It starts from 0, it goes to the right, your V should be a positive. At this point, your V is still a positive. Adakah dia patah balik? Tak ada patah balik. So your V is always positive because it's going to the right. However, you have a positive acceleration here, which means that your V keeps on increasing. Because your acceleration is positive. But when your acceleration has a different sign than your velocity, in this case, your velocity is positive, but your acceleration is negative. Therefore, your velocity will be decreasing. So tadi ada 3 positif, sekarang ni tinggal 2 positif and then 1 positif. So it slows down. Okay, so it depends on the signs. Sometimes you have negative V and positive A. So that is something you need to figure out lah, okay. Just know that kalau signs dia sama, speeding up. Kalau signs dia tak sama, slowing down. Okay. If the brakes are applied for 3 seconds, how fast is the car going at the end of the braking period? So it's asking what is the final velocity over here? Okay. So in this case, why did this person, orang yang buat example ni, kenapa dia break this motion into 2 parts? Part 1 and part 2. What was the reason? What is apa dia?
Velocity lain-lain.
Velocity lain-lain, betul. Tapi velocity kita memang semua lain at all points. Apa yang membezakan part 1 dengan part 2?
Acceleration.
The acceleration is different. So that is why this example, they break it into 2 parts. Let's say the entire motion, the acceleration is just 1.5. Then you don't have to break it into parts. Another thing that you need to note, apart from acceleration, kalau acceleration berbeza, divided into 2 parts. Kalau ada 3 acceleration, divided into 3 parts. Another thing is displacement ataupun velocity punya direction, displacement or velocity lah. So let's say you are going to the right, mula-mula x is positive, and then at this point you say okay, tertinggal back, so patah balik minus x, right? Your displacement is to the left now, ataupun your motion is to the left. So in this case this is positive v, and in this case this is negative v. So you can divide your motion into 2 parts. This is part 1 and this is part 2. Why? Because your direction of velocity is now different. First you were going to the right and then you were going to the left. So you can divide that based on the displacement lah ataupun velocity direction. So this is one way of dividing it into section. Another is the acceleration. Yang selalu kita akan tengok is acceleration lah. Okay, so I hope that's clear for everyone. Kenapa kita divide into 2 sections? Okay. So now, how fast is the car going at the end of the braking period is asking for V2, and how far has it gone? Daripada starting point to end point is asking for the displacement. Okay, does anyone have an idea on what to do? What equation should we start with? What equation should we start with? What is the first thing that we need to find? Anyone? What's the first thing? Bantai lah, bantai. It's okay if it's wrong. What do you think? Malu lah korang ni. Apa dia? Velocity.
Velocity.
Velocity V1 ke V2?
S.
V1.
V1. Okay, some of you are saying V1. Another is saying SS. S1 ke S2?
S1.
S1. Okay, so kita cari V1 and also kita cari, what's going on? Kita cari V1 and another kita cari S1. Okay, if I wanted to find V1, what equation should I use?
U plus AT.
V equals to U plus AT, okay?
U plus AT.
Right. So V1 equals to U plus AT. So because I'm trying to find for V1, this equation should also be U1 and A1 and T1. Jangan cari V1 tapi pakai value T2, pakai value U2, jangan. So it has to be consistent. Semua juga macam kita cari Vx, Ux plus AXT. Semua kena sama. Vy, Uy, Ayt. Tapi yang ni sebenarnya kita tak masuk lagi. So semua kena sama, kena consistent. Kalau pakai kat sini 2, semua 2. Sini 1 kan? So everything is 1. So we know what is our U1, it's 0. And then our A is plus 1.5, and we know the time, it's 5. So can someone calculate this for me? 5 times 1.5,
7.5.
So it's 7.5 meter per second. So that is your V1. So V1 is equal to 7.5 meter per second. So the other group is saying, let's find S1. So what is the equation to find S1? What's the equation I should use? Anyone?
S equal to UT plus 1 square.
Okay, kita boleh try yang tu. UT plus 1 over 2 AT squared. And there's another equation, S equals to apa? 1 over 2 U plus V times T. But let's use the first one. Okay. So U is 0. So we are left with 1 over 2, 1.5. T is 5 squared. So what is my S over here? Can anyone calculate that for me?
18.75.
18.75 meters. Okay, so kita dah solve for the first part. Sama? Dapat sama ke? Tadi ada orang nak bagi saya jawapan. Sama ke tak dengan jawapan ni? So here we get the V1 as 7.5 meter per second, which is also the initial velocity for the second part. Okay, so your V1 is now your U2 because they are basically the same thing lah, the same point. We just divided into two sections. Basically, this guy becomes your initial and this is your final. Okay, so sama juga because we already used this equation. Let's just use it again for the second part. Let's use a different color for that. And kita move ke sini. So V equals to U plus AT, U2 plus A2T2. So U2 is 7.5 plus minus 2, T is 3. So you get whatever that V is. And can someone calculate that for me? And S2 is 1 over 2 A2 T2 squared, which is minus 2, and this is 3 squared. Cancels out, this is 9 meter. So what's the V2 over here? Minus 6.
1.5.
Okay. So now it's asking how fast is the car going at the end of the braking period? It's asking for V2. So the answer is 1.5. So this is answer for A. And then B, how far has it gone? B is asking you what is the total displacement of this car because it's asking how far has it gone. So you need to add in S1 plus S2, which is 9. So 18.75 plus 9, okay? Because linear kinematic dah nampak senang kan? So it gets kind of boring. 18.75 plus, kenapa saya tulis 27 kat sini? Oh, because saya terus add, okay, 27.75 meter. So that is your answer for B. Okay, so I hope everyone is comfortable with linear kinematics already at this point, because now we are going into free fall, which is another concept. Okay, so free fall, what is the definition here? So all objects moving under the influence of gravity only are said to be in free fall motion. Dia kena under influence of gravity only, only. All objects falling near the Earth's surface fall with a constant acceleration. So this is Earth and this is you falling because you're not Superman, so jatuh. So you are actually free falling into Earth or ataupun towards Earth. And your acceleration is minus g or minus 9.81. We call this as free fall. Okay, you are accelerating due to gravity and it is 9.81 meter per second squared. Why is it a negative? Because it's going down. Acceleration is a vector, therefore it's a negative. Okay, and then we typically write this as g. I think you know this. G is equal to 9.81. Remember, it's a vector, so if you're going down, it's a negative. If it's going up, it's a positive. But when does it go up? It doesn't ever go up, right? And then it is always toward the center of the Earth. So let's see, kita nak cari nama hari ni. Mai dengan Najla lah. Okay, so Mai is over here. Okay, Mai is there and Najla is here. And Mai is saying, Najla datanglah sini. Sorry, kenapa nak datang pula kan? Kita cakap pasal gravity, sorry. So Najla said, okay, I'm being attracted by Earth's gravity towards this way, right? Because if Najla falls, she falls this way. But Mai said, oh, is that so? Is gravity this way? So Mai pun nak try nak jatuh ikut gravity. So dia pun ikut macam ni. So this is not right. So gravity dia towards the center of the Earth. Because Najla is here, that's why the gravity is this way. But in Mai's case, Mai is at the other side of the globe. Her gravity is this way because it is towards the center of Earth. Dia bukannya selari kat semua tempat. So it's towards the Earth. So Mai yang dekat Antartika, tak tahulah Antartika ke kat mana. And Najla which is in Singapore, tiba Singapore pula. So diorang punya I would say jauh. Betul lah. Okay, cukup jauh. So gravity dia towards the center of the earth, and you can't say Najla is this way, so my pun kena this way. So it doesn't work like that. So the direction is always towards the center of the earth. Okay. Ignoring air resistance. Untuk physics, kita selalu ignore air resistance. Kalau orang yang letak air resistance dalam equation dia tu, kita panggil apa? Rebel. Panggil rogue lah. Dia macam, kau kenapa buat susah, buat diri sendiri susah kan? Macam tu lah. So typically in physics, we just ignore air resistance. Siapa yang letak tu macam mengada-ngada lah. Sebab it really messes up all calculations. It's hard. And assuming G doesn't vary with altitude over a short vertical distance, free fall is constantly accelerated motion. Okay. So we have our linear kinematics. Now instead of using A, you can replace this as minus G. Or if you like, you can just put A equals to minus 9.81. Works as well. If you want to maintain this equation like this, you can. Or if you want to write it like this, U minus GT, you can do that as well. So this is the equation, you are going to use acceleration as minus G for free fall motion. You are going to use acceleration as minus G or minus 9.81 for free fall motion. Okay, nanti kita akan tengok how do we use it. So in this case, kita tengok we have a ball over here. We have a ball over there, over here. So I have this ball, I'm holding this ball and then I do like that. I'm just throwing it and the angle is with respect to the x-axis is 90 degrees. There's no angle. Basically, I'm just going vertical. I'm just shooting my ball vertical. So ataupun angle 90 degrees lah. So this ball goes up, 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 up. I start with an initial velocity, U. I go up, but I know that my ball will be influenced by gravity. Okay, I know my ball will be influenced by gravity, and the gravity is going down. So even though my ball is going up, 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 the velocity will increase or decrease. What will happen?
Decrease.
It will decrease. Kalau kita bayangkan pun, when we throw our ball, kat bawah ni laju, ke atas ni, dia jadi makin slow, and then jatuh. Betul tak macam tu? So what happens is your U is positive. It's going up. It's going up, up, up. But your acceleration is negative, minus G, right? Remember, your signs are different. Therefore, the velocity will be decreasing. So at this point, your V is a smaller value than your U. Okay, dia akan naik. Lepas tu at one point, the V equals to 0. The V equals to 0, baru dia boleh turun. So dia start pada, let's say dia start daripada 20, naik, berkurang, sampai jadi kosong, and then dia jatuh, because kat kosong dia tak boleh naik dah lah. When it is 0, it can't go up. There's no velocity to go up, basically. So it's 0. So where should it go? We still have A equals to minus G. So it has to come down, and now my initial velocity is negative U. And then it goes down, 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 down. My acceleration is minus G. Now, is my speed increasing or decreasing?
Increasing.
It's increasing, but negatively. It's going downwards lah. The sign of my velocity on the right side or the red motion is the same sign as my gravity. So they have the same sign, both are negative. Therefore, from 0, tadi start dengan 0 kan kat sini. Ataupun kat sini something that is tak banyak lah, let's say 1 ke, minus 1. You will get something that is bigger down here, minus 19 ke, minus 20 ke. So it will be increasing but negatively. Okay, so now the fun thing about free fall, fun pula kan. Free fall yang symmetrical, macam ni, kita start from one position, tolak ni atas, and dia jatuh balik dekat tangan saya. Dia naik atas and jatuh balik dekat tangan saya. So I can say that this free fall motion is symmetrical. And a symmetrical free fall motion will have equal values. Walaupun sign dia lain, they will have equal values. So let's say I started with 20 meter per second. When my ball lands, before it touches my hand, the velocity will be minus 20 meter per second. And then kat sini, memang V equals to 0 lah untuk dua-dua. And let's say at this point it is 1 meter per second sebab dia kena berkurang kan, berkurang sampai jadi kosong. This guy over here at the same level, tak sama level lah pula, assume dia sama level, this guy is 1 meter minus 1 meter per second. And kalau kat sini, it's not 10. Kalau kat sini 3, sini pun minus 3. Kat sini 10, sini minus 10. So that is for a symmetrical free fall motion. Ada ke free fall motion yang tak symmetrical? Ada. That is when you start from here but you end here. So you start from a height 10 meter tapi nak jatuh dekat ground. You are 10 meter. Uish, panjang gila. You are 10 meter, you are baling bola kan. Naik atas tapi you're not, tak sambut bola tu, so bola tu jatuh ke bawah. So that is not symmetrical lah. So you can't use this shortcut. So the left and the right side ataupun the black and the red is not equal. Now I say that the left and the right side, right? Tapi sebenarnya bila kita buat free fall, kita naikkan ke atas, dia turun kat tempat yang sama. So basically it happens on the same, at the same place. I hope I'm making sense. Alah, tak boleh buat lah. So basically the red line dengan black line ni overlap. So kita separatekan dia supaya kita tahu ada dua motion yang berlaku, going up and going down. Tapi in reality, my ball, this is my hand, buruknya. So my ball goes up here, it also goes down here. So the red and the black sebenarnya overlap. Kenapa kita separatekan dia? Kita nak tunjuk ada V equals to 0 and sini positive V, sini negative V. Okay? So that is your free fall. Okay, so recapping, taking initial velocity, free fall, an object dropped from rest. So let's say, saya tak boleh nak pick nama siapa-siapa, semua orang senyap je. Let's say Hazira lah, okay. Hazira dapat hadiah daripada ex dia Tak tahulah Hazira ada ex ke tak. Tapi Hazira dapat hadiah daripada ex dia and Hazira said dia nak buang hadiah ni. Dia dekat atas bangunan kan, dia tengah berduka cita. So dia nak lepaskan hadiah ex dia. So what happens? Dia jatuh. So this hadiah, kenapa hadiah dia macam bola? Hadiah dia macam ni lah, kotak. So hadiah yang jatuh ni is undergoing free fall. Tapi disebabkan Hazira dia lepaskan je, dia macam dia macam kecewa kan, macam lepaskan je. Macam tu je, dia tak adalah baling, dia tak jahat kan. So dia letak je, dia macam okay sila jatuh macam tu kan. So dia punya initial velocity is 0. So U is equal to 0. Okay, so that is her starting velocity ataupun hadiah X dia. Then taking upward as positive, use the kinematic equation. So we have our U as our U as 0. So because of acceleration minus G, this value will keep on increasing. Let's say kat bawah ni dia jadi minus 20. Dia increase tapi negatively. Hadiah X dia tu bila sampai kat bawah minus 20 meter per second. Okay, so macam mana kita nak tahu value minus 20 meter per second ni? So daripada linear kinematic equation. Okay, so let's try. If we started with U equal to 0, our A is minus G. Am I able to find the final velocity assuming that this height Hazira on the building is 100 meter? Boleh tak saya cari V dia? Hadiah dia jatuh. Boleh ke tak?
Boleh.
Boleh.
Okay, what equation should I use? So I have 100 meter. I have hadiah start dengan motion velocity equals to 0. A is minus G. Time tak tahu. Final velocity tak tahu. So how do I find the final velocity of hadiah X Hazira sebelum dia jatuh, sebelum dia cecah lantai? Kat sini lantai. Lantai.
The last equation.
The last equation, this one. Is it this one? Or not this one? What's the last
Yes.
equation? Oh, this one, okay. So V squared equals to U squared plus 2AS. In this case, dia terus substitute A. So 2 minus GS. Okay, so U is 0. 2 minus 9.81. What is my S in this case?
100 meter.
100 meter. Okay, everyone is saying 100 meter, okay. But the hadiah X Hazira ni, dia jatuh ke bawah. Is S a vector or not?
Yes. Negative 100.
So it should be negative 100. So motion yang ke bawah, displacement yang ke bawah, the S is a negative. If I'm baling bola ke atas, my S is a positive. Bola tu jatuh ke bawah, my S is a negative. This is the shortcut. If you want to know why it's a negative, basically because S is also equal to delta Y or in delta Y, sebab kita cakap pasal a Y axis. So delta always means final minus initial. And our final is 0 and our initial Y is 100, right? So you get a minus 100 over here. So this is why you have a minus 100. Tapi yang nak senang ingat, motion naik atas positif, motion yang ke bawah negatif. Walaupun dia datang daripada objek yang sama. S dia boleh jadi positif, S dia boleh jadi negatif depending on where it is. Motion going up, positive. Motion going down, negative. Displacement negative. Okay. So now that we have this equation, so now we can calculate it. All right, so 2 times minus 9.81 times with minus 100. Okay, so I get 1962. So I'm going to square root that and I get 44.29. Okay, now my question is 44.29. Our motion is going down. What is the sign of my V?
Negative.
It should have negative. So where does the negative come from in this equation? Where does it come from? Any ideas? So siapa nak teka?
Square root eh?
Negative U.
Yeah, square root. Ada orang ingat. Because we used square root. Kat sini square root, sorry. Kat sini ada square, sorry. So this square, when you square root something, 1962 something, whatever tadi tu. So your answer is plus minus, kenapa lah saya buang tadi? 44.29, right? And because we are very smart people or very smart human, we know that the velocity is going down. Therefore, we choose the negative sign. So your final answer should be 44 minus 44.29. If you give a positive answer, it is incorrect. Vector kena ada direction and also magnitude. So the direction should also be correct apart from the unit lah. So vector ni leceh ada sign, ada magnitude and also ada unit. So have to be very careful. So motion going down, let me recap. Motion going down, our S is negative. Motion going up this way, our S is positive. Motion going up, our V is positive. Motion going down, our V is negative. At this point, it is a V equals to 0. At this point, your A is minus G. At this side, it's minus G as well. Tak berubah, acceleration tak berubah. Walaupun motion naik, walaupun motion turun. Acceleration is due to gravity and gravity does not ever change direction. So it's always minus g. Okay, alright. So now that we found out what is our v, and kita tahu it's negative. What about apa tadi? Time. How can we find the time?
Use the first one.
Use the first one. Okay, kita akan cuba. Okay, in case you guys are not familiar lagi dengan saya, I don't mind if you get a wrong answer in my class, because we are here to learn, so it's okay untuk bantai. Okay, as long as bantai dengan berhemah lah. Okay, just don't be rude in class towards your friends and towards me. Okay. So the first one, v equals to u plus at, and v we already know it's minus 44.29, and my u was from here 0, kat sini dapat minus 44.29. So this is a 0 and minus 9.81 t. So we can just use our calculator. So the minus signs will be eliminated ataupun cross out. So we are good lah because time cannot be negative. So if you didn't put the negative sign here, your v would be positive and you would divide it with a negative acceleration and you would get a negative time. So tu dah memang salah lah. So if you get that answer, please go back to your previous calculations and see what you did wrong lah. Okay, so time cannot ever be negative. Time always positive. So time is 4.51 positive seconds. So the time taken for Hadia X Hazira untuk jatuh betul-betul dekat lantai ataupun jatuh kat tanah is 4.51 second. So lama jugalah nak sampai kan. Sebab 100 meters. Jauh juga. Alright, so that is your first example merepek. So now we go to our actual examples. Yang ni object thrown vertically upward, kita dah bincang pasal ni. Your U is positive here, your H is positive, this one your H is negative, time is always positive. If it's symmetrical, T1 is equal to T2. The time taken for the ball to reach this point is the same time for the ball from this point to reach the landing point. So T1 equals to T2. So the total duration of the projectile, of the free fall motion is T1 plus T2 or 2T1. This is the total time taken for the ball naik atas sampai balik ke tangan saya. Okay, so it's 2T1 ataupun just capital T. So capital T is the total duration. Okay, and you can see here that the acceleration is always minus g. Okay. Okay. So I told you just now that at the top, the V is equal to 0. The V is always equal to 0, tak kisah. Kalau kita ada situasi macam ni, okay, initial and final dia sama, V equals to 0. Initial kat atas bangunan, final kat tanah macam Hazira tadi, V equals to 0 kat atas ni. Siapa ni kat bawah ni? Anik dekat bawah, baling something, naik atas, terkena dekat atas bangunan, V equals to 0. Tak kisah macam mana pun, there will be a point where it achieves its maximum height that the velocity becomes 0. So velocity becomes 0 at the maximum height. Ini yang paling tinggi dia boleh pergi, maka di situlah V equals to 0. Always, for all free fall motions. And also for projectile. Kita akan tengok projectile later. Okay, so problem solving strategy. Read and understand the question as usual. Try to visualize. I would recommend you to draw. Kalau ada different acceleration, break it into sections. If you have different positive, negative, velocity ataupun displacement, break it into sections. Draw a vertical straight line to represent the free fall motion. Straight line, vertical. Macam itulah. And then indicate the initial and final level. So if you are breaking the free fall motion into two parts. This is your U, this is your V, this is your U, this is your V. Sorry, tulisan buruk. Okay, U. In your diagram, indicate the initial velocity, final velocity, acceleration, minus G, T, S positive, negative S. For each section of the motion. Determine the known and unknown values. Sekejap eh. Okay, so use the relevant kinematic equation to determine the unknown values and state your answer. Do not forget units. Okay, so let's do this example. A ball is thrown vertically upward with a speed of 25. So this is your ball and you throw it upwards and the initial velocity is 25 meter per second. How high does it rise? How long? It's asking you the maximum height. That's the first question, A. And then B, how long does it take to reach its highest point? So if we're breaking the free fall motion into two sections, we're going to say this as T1. It's asking for T1, the time taken to reach the maximum height. Sampai ke atas ni, nak tahu berapa masa yang diperlukan. So how long does it take to hit the ground after it reaches the highest point? So now it's asking T2. What is its velocity when it returns to the level from which it started? So we started with U and it's asking for the final V. So if we are breaking it into two parts, right? This would be our V2 lah. Would be our V2 and this is our U2 and this is our V1 and this is our U1. And the maximum height occurs here, max height. Okay. Velocity. So now it's asking for V2. How do I find A? What is the equation that I should use to find A? Nak tanya orang lah. Isma Nazmi. Macam mana nak cari A? Maximum height. What should I do? Orang lain get ready eh. How should I find the maximum height? Isma Nazmi ada kat situ ke? Are you there? Ke dah tertidur? Okay, so sangat memuskilkan. Ikri, how do I find the maximum height? Okay, Ikri is there? Yeah, okay, Ikri is there. Ikri?
Pakai formula.
What formula?
Pakai U plus negative GT.
U plus negative GT. So tajuk kat sini apa eh?
Itu adalah V.
V, okay. So what is the value for my U? Untuk cari maximum height ni. 25. Okay, so and then G kita tahu 9.81 and then T we don't know. V pun kita tahu ke tak?
Tak.
Is it V1 or V2 here?
0.
0.
0, right?
Yeah, okay, so korang, you guys are getting it. Because we are at finding the maximum height. So V1 is equal to 0. U2 is also equal to 0. So I can say V equals to 0, 25 minus 9.81 T. This solves for the time. Which time am I finding? Is it T1 or T2, Ikri?
T1.
T1, okay? So this is T1 and the answer is 25 divided by 9.81. So you didn't answer the maximum height. So what's the next step? 2.55. So what's the next step to find the maximum height? Saya nak cari S. Ikri lagi masih kat Ikri sebab Ikri tak jawab.
Formula.
Okay, formula mana?
Use formula S equal UT plus 1 over 2 negative GS.
Okay.
Negative G.
Okay, so in this case, your S positive or negative?
Positive.
Positive, because motion is going up, therefore your S is positive. Kalau motion going down, negative. Okay, sebab kita tengok kat section yang pertama ni kan, so positif lah. So S is 2 ASUT plus 1 over 2 AT squared. Silap. This is T. Okay, so UT, our U is 25. T is 2.55. 1 over 2, saya pakai orange, tak tahu. 9.81 and then this is 2.55. What is the S here? Can someone calculate that for me? Okay, tak nampak lah. So what's the answer, guys? Okay, anyone?
31.86.
31.86 meter. Okay, so that is S going up to the maximum height. What is the maximum height? What is the maximum height? Is it the same or is it a different value?
Same.
Same. Okay, it's the same because we assume that we started from 0. Okay, we assume we started from 0. If we did not start from 0, then your maximum height, I mean, kalau tanya pasal displacement terus tanya maximum height lah kan. But let's say you are on top of a building that is 10 meters in height and you have a displacement of 31.86. So you can say that the maximum height is 10 plus 31.86. Okay, but that's another story lah. So in this case, because we assume that we are on the ground, kita assume kita on the ground, kita bukan atas bangunan ke apa ke. So kita punya displacement start from 0 or our position started from 0. Therefore, the displacement adds up to become the maximum height. So this is the answer for A. Okay, so this is A. And then for B, thank you Ikri. So B, Ikri sebenarnya dah jawab juga. So B, he got T1 and also the maximum height. And what about T2? What should I do to find T2? Can I use the same equation as the one before? Let's just try. V2 equals to U2 minus GT. So now my U is equal to 0 because I'm starting from here. This is now my motion. My velocity starts from 0, ends up at some value that I don't know. So V2 tak tahu, U2 is 0 minus 9.81 T. T I also don't know, supposedly lah. Okay, so we'll just leave this one first and then we'll use this one again. S equals to UT. So I have a chat here. Ada orang nak jawab ke? Doktor boleh ke pakai S equals to 1 over 2 U plus VT? Okay, kita boleh try. Thank you for trying. 1 over 2. So Aiza nak pakai 1/2 U plus V T. So this is what Aiza wants to use. So we know that from A, we already know our maximum height. So we can use that. We can use that and say that we are going back down. So this becomes minus, our S earlier was 31.86. Now its motion is going down. The same value becomes minus 31.86, 1/2 U plus V. Our U is 0. We don't know what our V is. This is U. And we don't know what our T is. Konon-kononnya lah. Tapi sebenarnya kita dah tahu T kita apa. Our T should be equal to this guy. T1 equals to T2. Okay, so let's say kita pakai value T1 lah dalam ni. Kita pakai T1 dalam ni. Dalam T2. Kita pakai T1 equals to T2. Then we can solve for S. Sorry, we can solve for V. And if we use T1 equals to T2 in this guy also, we can solve for V2. Okay. So kalau you don't want to use T1 equals to T2, what can we do about this equation? V squared equals U squared plus 2AS. S kita boleh pakai. S sebenarnya boleh pakai sebab kita dah cari kat A. So S boleh pakai. T1 kalau kita nak assume tak pakai lagi, boleh. I don't know if I'm making sense to you guys. Tak apa, kita akan do more examples. Okay. How long does it take to reach the ground after it reaches the highest point? So T1 equals to T2. So it's just basically the same answer lah. 2.55 seconds. What is its velocity when it returns to the level from which it started? So let's find out. 0 minus 9.81, 2.55. Kita dah tahu jawapan dia apa. Kita nak tengok juga. Jawapan dia should be V equals to... Did we solve for V? We did not. Oh sorry, jawapan dia akan minus 25. Jawapan dia akan sama dengan U kat bawah ni. So dia akan jadi minus 25. This is our prediction yang sememangnya betul. So let's see. 9.81 minus 9.81 times 2.55, you will get minus 25. Jawapan dia memang minus eh. It shouldn't be a positive. Okay. And how do you know T1 is equal to T2? Because it is symmetrical. Is basically equal. Kanan dengan kiri ni sama kecuali signs. So time taken to go up is the same as time from up to down. Okay. Okay, let's do another one. So that is minus 25. Kita dah jawab D. C pun kita dah jawab. B kita dah jawab. A pun kita jawab. Okay. So this is the answer or solution. So they use V squared because U squared plus 2AS to find out the maximum height. 31.86 sama. How long does it take to reach its highest point? 2.55. Sama dengan jawapan kita. Okay, so and then, nak boleh stop. Okay, so how long does it take? 2.55 as well. How long does it take to hit the ground after it reaches the highest point? From here to here, 2.55. What is its velocity when it returns to the level from which it started? Kat sini, berapa velocity dia? Minus 25. Jawapan ni salah. Kena ada negatif. Okay. Okay, so kat sini dia punya plus minus dia hilang, dia tak bubur. So it should be negative sebab motion going down. Okay, so now I want to ask you guys to do it because no one is responding to me. So exercise 2.3, a ball is thrown directly downward. Okay, a ball is thrown directly downward. So like that. Okay, so it's from a height, sorry. With an initial speed of 8 meters per second. And from a height of 30, so this is 30. After what interval does the ball strike the ground? It's asking what is T for it to reach over here, the ground lah. Is my diagram correct or incorrect? Is my diagram correct or incorrect here?
Correct.
Correct.
Correct. So all the values are correct as well.
Negative 30.
Negative 30.
Yeah.
Apa lagi?
U equal to 8 meters.
U equals to?
Isn't it 0?
U equals to 0. Okay, some of you are saying U equals to 0. Okay, other guesses?
V equal to 0.
V equals to 0. So ada U ada, V equals to 0. Okay, lagi?
Negative 8.
Negative 8. So jawapan yang betul negative 8 Dia dah cakap initial speed dia negative, 8. And it's going down. So it should be a negative 8. Kenapa bukan 0? Because a 0 should start from the bottom. Macam ni. Naik. We start from, let's say we start from 8. Naik. Makin berkurang. Let's say this is 6. This is 5. 4. And sampai kat sini dia jadi V equals to 0. Bayangkan kita baling bola. Dia jatuh kan? Time dia nak jatuh tu, sebelum dia jatuh, V is equal to 0 and then negative 4, negative 5, negative 6, negative 8 at the same point. Macam tu baru ada this situation V equals to 0 ataupun U, V1 equals to U2. Okay, this is when your value at the maximum point becomes 0. Okay, tengok balik kita punya contoh tadi. Situasi daripada atas jatuh ke bawah tak ada kat sini. So dia kena ada lengkuk ni. Baru ada V equals to 0. Okay. So back to the example. So but it was a nice guess because it helped me to identify that you guys tak familiar dengan this projectile motion. Sorry, the free fall motion. Okay, so again, when does it become V equals 0 at the maximum height? When you start from the bottom. You have upward motion and downward motion, you have that V equals to 0. In this case, you only have the downward motion. So tak ada positif dengan negatif tu tak ada. So dia tak sempat jadi V equals to 0. So dia start dengan 8 minus, dia makin meningkat. Let's say bawah ni, dia akan jadi something bigger than 8. But it is a negative. Okay, so now that we cleared up that it's not 0, what else is missing from my diagram? Diagram pun kena betul because you use it for the equation, right? So what else is missing here?
V.
V, okay. V, I want to put my V here. V is unknown. T is also unknown. What about my displacement? So this is the height, 30 meter. And let's say this is 0 meter. Is this correct, labeling it like that? Betul ke salah? Terbalik. So atas kosong, bawah 30. But the question says from a height. Dari ketinggian 30. So tak boleh macam tu. So is this right or wrong?
Dekat tengah-tengah.
Correct.
It's correct. But kat tengah-tengah tu apa? S equals to?
Negative 30.
Negative 30, yes. So diagram saya correct. We start from 30, which is what the question says. And we land on the ground, which is a 0. But the displacement is minus 30. So if I'm using it in an equation, therefore, it should be S equals to minus 30. Kenapa? S is delta Y. And this is Y final minus Y initial. Y final is 0. This is where the ball ends. 0 minus, this is where the ball started. Minus 30. So it's minus 30. So S equals to minus 30. Betul Alright. So let's use the equation. Let's say we want to find out, but let's see, after what interval does the ball strike the ground? It's asking for the T. It's not asking the V. It's asking for the T. What equation should I use? Saya pun tak tahu. S equals to Let's say
UT plus
UT plus
negative GT squared.
negative GT 1/2 GT squared. Okay.
1/2 negative GT squared.
Okay, so positive negative GT squared. Okay, thank you. So S equals to UT plus 1/2 minus GT squared. So S in this case, kita dah tahu it's minus 30. Minus 30 and your U is minus 8. T tak tahu plus 1/2 minus 9.81 and T squared tak tahu. Okay, so now I have like this equation yang ada squared dengan T and then the minus 30. How should I use my calculator to solve for this? Kita dah buat dah rasanya benda ni. How should I use my calculator? Does anyone remember? Or ke saya tak buat kelas korang? Ada tak kita pakai? Tak ada Ya ke? Okay, saya cerita balik So tekan mode, your calculator tekan mode, so you go into comp dengan computation dengan complex, I think. And then tekan mode lagi sekali, ada equation. Okay, I think you guys know this. So tekan equation number 1, right? It says unknowns 2 and 3. That this is not the one that you want. So you press to the right. So dia bagi degree. Degree kita adalah 2. This is our degrees. Degrees of our equation is 2. So tekan 2. So our A kita ada A, B, C. So kita rearrange ni dulu. We rearrange this equation so that we know what is our A, what is our B, and what is our C. So this should be our A. This should be our B. Ni nombor 2 kan? So the A. Ni nombor 1. This is B. And this is T to the power of 0, which is 1. So that is why it's just minus 30. So this is your C. Okay, so tapi T to the power of 0 ni tak ada situ. Okay, so now I rearrange this. I get minus 9.81 over 2 T squared minus 8T. And I bring this over to here plus 30. So this is equal to 0. So this is my A, B, and C. If I want to flip the signs, boleh sebab it's equal to 0. So this become positive, positive, negative. We'll get the same answer. Okay, so now I'll just leave it like that because I'm scared to change it. 9.81 over 2 is my A. Sorry, minus 9.81 divided by 2 is my A. My B is minus 8. My C is positive 30. So I get 2 answers here because it's a quadratic equation. So my T1 is equal to 3.42 and number 2 answer is, sorry, this is minus. My number 2 answer is 1.79 seconds. So I have 2 answers here. Which answer should I choose?
Positive.
1.79.
Okay, we are smart humans, so we choose the positive sign because time is a positive. Okay, let me try if kita punya signs flip. I want to try if it works or not. So positive 4.905, positive 8, and minus 30. So I get positive 1.79, negative 3.42. So boleh if you don't like this negative signs, I usually don't like the negative signs, and I make this as my negative, boleh, you will get the same answer. Why does it work? Because this is equal to 0. Basically, the signs can be flipped around. Tak kisah. Okay, so use your calculator. I think you guys know how to use it. If not, ask your friends. Benda ni saya pun tak pakar calculator. So the answer, always pick the positive one. And if you get your S incorrectly from the start, you will get the wrong answer. So it is very, 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 very important to draw and to know what is your S. Penting untuk draw. Bila tak draw, selalunya kita salah. Selalunya. Most of the time. 99% of the time. Okay, so we answered that one. So the solution is 1.79. Yay. So dah habis free fall. So let's take a 7-minute break because it's in the evening. Kita pun penat. So let's come back at 3:15 and kita akan sambung with projectile motion. Okay. So see you in 7 minutes. Kalau ada soalan boleh tanya.
Doktor,
Yes.
nak tanya yang soalan tadi tu,
Mhm.
kan bola tu kan jatuh ke tanah kan? So
Okay.
kita boleh assume dia punya V tu equal to 0 tak? Ke kena cari juga?
Kena cari juga. Okay, that's a good question. Saya terlupa nak cover about that. So kita nak cari velocity before it touches the ground sebenarnya. So V is before it touches the ground, because when it touches the ground, when it touches the ground, maksudnya motion tu dah tak ada dah. It's not part of the motion anymore. It's the end. Bukan it's the end, it's after the end. So the end is this guy. Ni kalau kita masuk movie, yang ni dia punya ending script. Ada director, tunjuk pelakon ni semua, bla bla, ada lagu semua kan. So we want to know what is the V at this point. That is before it touches the ground. When it touches the ground, keluar movie. Dah tak, it's not part of the motion anymore. It's no longer the free fall. It's not part of the free fall. I know all free falls end up with V equals to 0, but the V equals 0 is not part of the motion. Dia dah bukan dalam motion tu lah. Okay. So kita nak tahu V sebelum dia cecah lantai. I think I have to mention this again when everyone is back. Thank you for
Okay.
reminding me.
Thank you, Doktor.
Okay, I hope everyone got a good break sekejap and refreshed for the next subtopic, which is projectile motion. Oh, sorry, before that, one of you guys tanya kenapa bila bola reaches the ground, right? Why is it not equals to 0? V equals to 0, U equals to 8, V equals to 0. Sebab dia cecah lantai kan? And bila cecah lantai, the motion stops. Therefore, the velocity should be 0. But you're right, betul. But linear kinematics, when we use the equation for linear kinematics, we are trying to describe the motion, right? Describe the motion. And we want to know what happens before the ball touches the ground, because when it touches the ground there's no more motion left. There's motion tu dah tak ada dah lah sebenarnya. So bayangkan kalau kita tengah tengok movie and ke akhir movie tu ada trailer, bukan trailer, ada macam script punya apa, penghargaan kan. So penghargaan tu is this part, penghargaan. It's still part of the movie walaupun hujung-hujung, it's still part of the movie, right? And it's relevant to the movie. But when the movie switch off and you go out of the cinema, walaupun you're still in the cinema, but it's no longer relevant to the movie experience. You're going out. So V equals to 0 ni dah tak relevant to the motion. Walaupun nampak macam it's part of the motion, but it's no longer part of it. Nampak je macam, tapi tak. So when we use linear kinematics, do not use your V as equal to 0 because it's not part of the motion. Bila dah cecah lantai tu, ada velocity. Bila dia dah cecah lantai tu, ada velocity, and bila dia cecah tu, what am I saying? Bila cecah tu baru jadi kosong. So sebelum cecah tu yang kita cari. Okay, just like split second before it touches the ground. Okay, so that is part of the motion. When it touches the ground, korang dah keluar cinema. So don't put V equals to 0. It's wrong. Linear kinematic is describing the motion. Remember the first part I told you about linear kinematic is describing the motion. So when you touch the ground, it's no longer part of that motion. You are not describing anything really. The ball is dah tamat dah. Riwayat kehidupan seekor bola. Sebiji bola dah tak ada. Okay, so dia dah settle. So kita nak tahu before dia cecah lantai. So do not put V equals to 0 . Okay, so I hope that was a really good question. Saya lupa nak cover pasal tu. Okay, so now we go into our projectile motion. Projectile motion, how is it different than free fall? So when we talk about free fall, we are just focusing on the y-axis. We go up and then we go down. So it's pretty simple. And our linear kinematic, kita boleh divide into two parts where this part is equal to V equals 0, assuming that we have a positive and negative. Kalau kita start from the top and go down, then if we have some initial velocity, then this is not equal to 0 lah. Sometimes it can be equal to 0 walaupun start daripada atas. That is when Hazira jatuhkan hadiah X itu, dia letak je kan. So jatuh tu boleh U equals to 0. So boleh situasi U equals 0 tu wujud. Tapi kalau soalan cakap ada initial velocity dari atas, then your U is not equal to 0. So it depends on the question. Okay, so free fall up and down, right? Projectile, you have the X and the Y component. So now, how do you throw a ball so that it has the X and Y component? You have to have some angle. Remember I told you tadi kita baling bola 90 degrees, up, down, macam tu je kan? But now imagine you are throwing a basketball. You throw a basketball like this, right? Tak tahulah korang balik basketball macam ni ke? Tak lah kan? So it has to have some angle. So imagine this is your basketball. You have to have some angle for it to go like this, and then this is your hoop. So projectile motion, yes, basketball goes into a projectile motion to go into the hoop. Yes. So when you have some angle that is not 90 degrees, you will have an X and Y component. So now it becomes a slightly tricky, tapi lebih kurang je dengan free fall. Cuma kita kena bahagikan into the X and into the Y. Okay, so this projectile motion, kita go over like this. And when we reach the top, we still have V equals to 0. When we go up here, our V is positive. When we go down here, our V is negative. Sama macam free fall. And then when we, our displacement is also positive, going here, and then going down here is negative. Now, what's the difference here? Our V direction, alamak terkuang pula. Our V direction, let me use a bigger marker, this one. Our V direction is here, right? This is our V. When our V has some angle, we need to resolve it into its X and Y component. Sama juga dengan S. Our displacement is going this way. It has some angle. It's not 90 degrees. It's not in the Y, it's not in the X. So it's in both. So if this is your S displacement, you have the SX and you have the SY. Okay, so each point you will have that X and Y component. And what about at V equals to 0? At V equals to 0, this is actually going, when you throw a basketball, right? When you throw a basketball, it's going to the right, always, right? It's going forward always. It's going forward. Therefore, your Vx, bayangkan your Vx, you're throwing the basketball, the X direction of that ball is always positive, but your Y direction is, first it was positive and then it went down, it's negative, right? So in this case, the V that is equal to 0 here is Vy, it's not Vx. Vx is always positive. Vx cannot be 0 because Vx is always to the right. So Vx is always positive. Bila dia nak jadi 0? Sebab tak boleh, dia always positive. Dia tak sempat jadi 0 pun. So Vy naik, this is positive Vy. Kat sini reaches the maximum height, goes down, negative Vy. Okay? So what about the acceleration? Acceleration is a no-brainer. Acceleration is always negative g. Going up, negative g. Going down is also negative g. And I missed the negative sign here. Okay, always negative g. Okay, so that's your introduction to projectile motion. So let's take a look at the equations. Okay, so we are still using linear kinematics now. We are using linear kinematics in the X component and for the Y component. So itu je perbezaan dia. So in this case, for a projectile motion, we talked about this. We have A equals to minus G, but G only acts in the Y axis. G does not act in the x-axis, so this is not right. So G only acts in the y-axis, therefore acceleration only has minus G in the y. This is y and this is x. Minus G is only in the y-axis. Okay, so it's only AY equals to minus G. Our AX is equal to 0. Kalau kita punya AX ada positive value, then our velocity would be increasing. Boleh lah, sebenarnya boleh je lah. But soalan biasanya tak ada lah. Okay, untuk soalan ni tak ada. Untuk projectile motion, we assume that our X component acceleration is 0. The only acceleration that we have is in the y-axis and it is due to gravity. Okay, so that is X and Y. Okay, what else? Now we talk about the velocity of projectile motion. Like I mentioned to you before, we start with an initial velocity. At any point, I am able to resolve it into its component. Dekat sini, I want to know what is my Vx and Vy. Therefore, it will be, it's going this way, right? This is my V. So this is my Vx positive, and this is my Vy negative. What about at this point? This is my Vx and my Vy tak ada komponen sebab dia hanya ke sini. So my Vy is 0. Vy equals to 0 at this point. Vx ada komponen. What about at this point? This point my Vx is positive, my Vy is negative. At this point, your V is like this. Vy is positive, Vx is positive. Okay? So initial velocity is given by this equation. We know this. This is resolving it into the x component. Our angle is touching the x-axis. Therefore, our ux gets the cosine. It's V naught. It's V naught. It's V naught. So ux equals to V naught cosine theta, because the theta is touching the x-axis. What if my theta is not there? My theta is not here, but it is here. What should my ux equation be?
Sine.
It should be a sine, right? Betul. So it should be a sine theta. V naught sine theta. If my theta is over here, whoever touches the angle gets the cosine. And in this case, if my angle is over here, my uy, my initial y component velocity will be V naught cosine theta. Kenapa? Sebab my angle is over here and it is touching the y-axis. And for this guy, it's not touching the angle, therefore it gets the sine. But in this case, gambar yang sebenar, our theta is touching the x-axis. So our equation should be ux V naught cosine theta. So terbalik. Whoever touches the angle gets the cosine. Okay, and this guy should be sine. So ada kat sini So ux V naught cosine theta, uy V naught sine theta. And for the final velocity over here, okay. Final velocity kenapa V naught? Oh, sorry. So dia pakai equation V equals to U plus AT. Tapi dia tak tunjuk kat sini. So V equals to U plus AT, dia pakai equation linear kinematics. Dia nak cari V. V in our case, this is UX, VX, VX. This is AX and this is T. T tak ada component because it's a scalar. So UX in this case is V naught cosine theta plus our AX we already know is a 0. Therefore, this is not relevant. So our Vx is actually V naught cosine theta, which is equal to Ux. Sama. So what I can say here is that your velocity in the x direction is the same from the starting to the end. It's a constant velocity sebab acceleration is 0. Constant velocity equals to 0 acceleration. Okay, so from the start to the end, your x component velocity is equal. So if it started from 10, the end is also 10. Okay, yang berubah kat sini is your velocity in the y. So you started with uy v naught sine theta, and using the same linear kinematic equation, v equals to u plus at. Kat sini dah pakai v naught sine theta as the u, and the a is g minus g and t. So your value, this guy, let's say it's a positive, minus dengan something, so it becomes smaller and smaller sampai dia jadi kosong kat sini, and then it becomes negative, negative, negative. Okay? So for your vertical motion, you have this component here, minus gt. For your horizontal motion or your x component, your a is 0, so that is why tak ada apa-apa kat sini. So it's just vx equals to ux. Okay, so your velocity in the x component tak berubah. Yang berubah adalah velocity in the y. Okay, next. So kita dah cakap pasal acceleration, we talked about initial velocity and also the final velocity. And let's talk about the time interval. Kat sini cakap, okay, the velocity at any point is the vector sum of the two components. Let's say you know what is the Vx here and what is the Vy here. Semua juga macam chapter 1 punya cerita vectors. If we want to know what is the V acting here, then we use the Pythagoras theorem, Vx squared plus Vy squared. Okay, and sama juga if you want to know the angle of this guy with respect to the x-axis, therefore you use the inverse tangent Vy over Vx. Sama je. This is all vectors. So you are using the equation from chapter 1. Okay. So we know acceleration. Kita dah tahu pasal velocity. Time, tak cerita lagi. Now we talk about displacement. Okay, so it's asking you what is the displacement when it has traveled for t equals to 10 seconds. Contoh what is the displacement when it has traveled for t equals to 10 seconds and u equals to 20 and apa lagi? Acceleration is g. So this is uy. Kejap. Ini gangguan. Where's the phone? Watch TV first. Aduh. So let's continue. Let's say I have t equals to 10 seconds, uy equals to 20 meter per second. Yes, 20 meter per second positive. This is what the initial velocity in the y component. Contoh Okay, so I want to know what is my displacement after 10 seconds. So use the linear kinematic equation. Jangan tengok ni dulu. S equals to the most suitable one that I should use is ut plus 1 over 2 at squared. And u is 20. This should be sy. This should be uy. And this should be ay. So uy times t plus 1 over 2 minus 9.81 t squared, and you can solve for the sy. So this is sama je, pakai linear kinematics, only that you have to know what is the component of each, x dengan y. You have to know what is the acceleration in the x and y. You have to know what is the velocity in the x and y, initial dengan final, and then the time interval is a scalar quantity, so the time taken to reach this point is the same for x and y. So kalau kita dah travel xx by this much and sy by this much, it's the same time taken. Time taken to reach here is the same time taken to reach here. They overlap. You can't have different times for x and y. Dia kena sama. Okay? Time is not a scalar. Time is not a vector, it's a scalar. And time is always positive. Okay. Now let's take a look at this equation. So it says for horizontal motion, s equals to ut plus 1 over 2 at squared. And we know that for horizontal motion, our a is equal to 0. So that's awesome. So we are left with s equals to ut. And in this case, I did not give you your uy. So it's just v naught cosine theta, whatever this value is, because this is your ux over here and times with t. So your time is x over v naught cosine theta. They just rearrange. You don't have to memorize this one. I can't emphasize this enough. Do not memorize. Just know the 4 linear kinematic equation. Jangan memorize time equals to x, blah, blah, blah. V equals to ni. Tak payah. Ingat yang 4 linear kinematic equation. Because this does not apply to all equations. The linear kinematic equations applies. Okay, yang ni ikut situasi. Okay, so vertical motion s equals to ut plus 1 over 2 at squared. In this case, we know our a is minus g. And our u is v naught sin theta. Ataupun value yang saya bagi ni, kalau nak pakai problem yang saya bagi itulah. And then t, dia substitute benda Allah ni. Okay, so it should be t lah if we didn't know this solution. So v naught sin theta t plus 1 over 2 minus g and then t squared. This is t squared. So dia rearrange this. Dia rearrange to show that dia nak tunjuk this one ada to the power of 2 x dia, and this guy to the power of 1, and this guy mana constant dia. So this constant is here. So this guy is the x to the power of 0 y. So it's showing you that this equation is actually a quadratic. So the projectile motion should look like a parabola, which it does, right? The projectile motion looks like a parabola or which is described by a quadratic equation. What is a quadratic equation? This guy, something that has to the power of 2, to the power of 1, to the power of 0. Okay, equation yang ada degrees 2. So projectile motion is described by this equation. Okay, is it important to know? No, not really. It's just like introductory math physics lah. Okay, do you have to know it? No. If you are interested to explore more, you want to do it for your mini project, by all means, boleh. It's very interesting if you want to dive deeper. But is it important to know for your exam? No, it's not. You're not there yet. Ni macam higher level lah. Okay, kita relate maths to physics tu dekat level yang higher. I would say kat masters pun ada lagi benda-benda ni. Okay, I'm not physics degree, by the way. Okay, so this is our parabolic equation. Y equals to ax squared plus bx plus c, and it looks like this, and it fits. Okay, so the shape of the path is a parabola. Okay, so we already know how to find our displacement. We already know how to find acceleration, initial velocity, final velocity, displacement. Now we want to know what is the maximum height. Like free fall as well, we divide this into two sections. This is V equals to 0, V1, and this is U2. But in this case, it only applies for V1Y equals to U2Y equals to 0. This does not apply to 0. So you can only find the maximum height. Dah nama pun height kan? For SY. Maximum height is SY when the final velocity in the Y is equal to 0. Okay, I hope this makes sense. But kita dah belajar banyak dah pasal linear kinematics. So when we are talking about maximum height, we are talking about the y-axis. Therefore, the velocity is also the y-axis punya velocity lah, Vy. And acceleration pun kena y-axis acceleration, which is gravity. Okay. And projectile motion is also symmetrical. Therefore, if the time taken to reach from here, the time taken from here to reach the maximum height is t. Therefore, the time taken from the maximum height to the landing point is also t. Sama, the same like free fall. So t equals to 2t. Okay, so t is the whole duration. Okay, kita dah cakap pasal maximum height. You know that you have to divide it into sections. And then we have range. Range is actually the maximum x displacement. Tadi maximum height. And ni maximum x displacement or range. Okay, it is denoted as capital R. Okay, this is the capital R here. So you have maximum height, which is y-axis. You have the maximum x displacement known as range or capital R. Okay, so R displacement, the time taken to reach the maximum x displacement is t equals to 2t. The maximum height, the time taken to reach the maximum height is t. So this is something that you need to be careful. Jangan pakai the same time to find the maximum height and the same time to find range because they occur at different points. The maximum height happens here. The range happens here. It's different points. So the time should also be different. Kalau dua-dua kat sama point, then yes, you have the same time. But if they are at different places, the time should be different. Jangan pakai masa yang sama lah. Okay, so R is 2t. The rest should be the same. So here dia pakai s equals to ut plus 1 over 2 at squared. But in this case, the G is 0. Kenapa dia letak G? So kat sini letak kosong. Okay, so betul. They cancel out. So you are left with, this guy is ux. Okay, the initial velocity in the x component. This guy over here. And this is t. Kenapa dia letak 2v0 sin theta g from equation 1? Mana dapat entah? Sekejap. Oh, it's from here. Dia dah pakai, dia rearrange equation je lah. Do you have to memorize this equation? No, you just use the linear kinematics. You will get values, you plug in the values, you get the answer. You don't have to solve it in variables like this. Okay. Okay. No need for this one. Okay, so range and height of projectile motion. So here it's saying complementary values of the initial angle result in the same range. What does complementary value mean? Complementary means that when you add them together, x1 plus x2, you get 90 degrees. So for example, 15 degrees plus with, is it 75? 75 will get you 90, right? So 15, a projectile motion with 15 degrees will have the same range as a projectile motion at 75 degrees. For example, sorry, terlebih pula. This is 15. Tahulah. This is 15 and this is 75. You end up at the same point. Okay, you will get the same range, not the same maximum height, but the same range. The maximum height is different. This is the maximum height for this guy. This is the maximum height for this guy. Okay, so it's different, but the range is the same. So do you need to know this? You can if you want a shortcut, but you won't always get values like this lah. Okay, so my take on this is just use the linear kinematic equations. Don't try to go for shortcuts, selalunya akan mess up somewhere. Okay, so let's try another complementary angle. 30 and 60 will get you 90. So we are expecting 30 range and 60 range to be the same. So 60 is this guy and 30 is this guy. You get the same range. Tapi maximum height dia berbeza. Okay, so it's just like FYI. For your information, but it's not really important. Okay, so now we go. Let's try together. Okay, I'm kind of tired of talking. I want to ask someone to help me. Can I get Faris? Faris to help me. Is Faris there?
Yes, brother.
Okay, so I want us to try this together. Let the launching angle and speed be 30 and 50 meter per second. What would be my initial x velocity? What should it be? My initial x velocity. Sorry, tertutup pula. Kejap. Okay. So this is x and this is y. What is my ux? Paris?
Sini.
Okay, so kita ada V. Okay, so let the
What's the
launching angle, macam ni kan. Kita launch a ball, let's say. The angle is 30. Okay, saya punya lukisan saya ingat pula. The angle is 30. So I have the value V equals to 50. This is my U lah. What is UX? Saya lukis gambar dah.
Oh, guna cos.
Okay, guna cosine, which is, what's the equation?
50 cos 30.
50 cosine 30. Okay, betul. Thank you. And then Akila, can you tell me what is the UY?
50 sine 30.
Okay, 50 sine 30. Thank you. And then Atira Najwa, can you tell me what is the acceleration in the X?
Zero.
0. Okay, good. Aliman Zafran, what is my AY?
Negative G.
Negative G ataupun minus 9.81. Okay, I think everyone is like panicking. Okay, aku kena bangun sebab doktor panggil. So Ifa, can you tell me how do I find my Vx? How do I find my Vx? Ifa is there? Knock knock.
Yep.
Okay, ada.
Ada.
Macam mana, Harry? Kalau pakai linear kinematic, equation apa? Kita ada U, kita ada A. Equation mana kita boleh pakai? Anyone wants to help Ifa?
Sorry, Doctor, I'm blur. Sekejap.
Okay, stay with me Ifa. Kita akan cuba ask Ifa again. So anyone else wants to help Ifa here? What is the equation that Ifa should use?
V equal to U plus 8.
Okay, V equals to U plus AT. So UX plus AXT. In this case, the AX is 0. So Ifa, what's the answer? Oh Ifa, dah tulis dah kat sini. What's the answer?
Saya sekejap.
Okay.
Is it 43.30?
Saya pun tak tahu. Macam mana awak kira tu? 43.30 tu kira macam mana?
By UX.
By UX, betul. So Vx equals to Ux. That's the answer. So the final velocity in the X component doesn't ever change. Okay, lepas ni Ifa mesti ingat sebab saya dah panggil. Okay, next. Siapa lagi saya tak pernah panggil Alisa Nazir, can you tell me the Vy? What is the equation that I should use to find Vy?
Ui equals to Ui minus GT.
Minus GT, okay. And Uy pakai ni, GT, okay betul. So that is how you find the Vy lah, okay. Sebab at this point kita tak tahu lagi problem dia macam mana kita nak buat. Kita buat equation dulu before kita attempt. Next, how do I find the maximum height? Saya nak cari siapa Oh, kalau soalan maximum height ni, dia ada satu je benda yang kena buat. Apa dia? Kalau soalan maximum height ni. Yang paling penting sekali. Okay, saya nak tanya siapa? Wasilah dah pernah panggil, Taibah dah pernah, Sharifah dah pernah, Rai dah pernah, Raden dah pernah. Khalida saya tak pernah. Okay, Khalida, are you there?
Yes, Doctor.
Khalida, okay. Kenapa suara Dr. Kowi? Okay, what is the most important thing to remember when you're solving maximum height? Okay, saya lukis saya bagi hint. Kat sini, apa yang kena ingat? This is maximum height. Apa yang bila saya lukis macam ni and saya letak macam ni, apa yang kat atas ni? Apa yang kena ingat? Anyone wants to help Khalida? Kenapa Khalida tak jawab? Khalida is missing.
Equal to 0.
Betul, V equals to 0, betul. When we are talking about maximum height, tak kisah free fall, tak kisah projectile, we always know that V equals to 0, assuming that we start from ada motion yang ke atas and motion yang ke bawah. Kalau kita start daripada atas and dia cakap ada initial velocity, then benda tu tak boleh pakailah. So kita assume bila kita naik dan menurun, kita ada this lekuk ni kita cakap V equals to 0. And lekuk tu juga is the maximum height. When we get our maximum height, kita baling bola, maximum height, V equals to 0, jatuh. Okay? So that is the most important thing. So if I know that my V is equal to 0, how should I use my equation here? Boleh ke pakai dalam equation ni? Nak panggil nama lain pula ke? Okay, saya panggil Nurin Hazwani. Nurin tak pernah panggil lagi. Nurin, are you there?
Yes.
Okay, so how do I find the maximum height in this situation? What is the equation that I should use? Nak pakai ni boleh, tak nak pakai ni pun boleh. What is the equation that you want to use to find the maximum height? Nurin? Are you there? Lampu saya ni flickering pula. Alamak, putus-putus. Okay. Hello, hello.
Hello.
Aha, okay ada. Okay ada. So equation mana yang awak nak pakai? Nak cari maximum height. Nak cari SX ke? Nak cari SY ke? Okay, boleh teka, tak apa, salah tak apa.
Why?
Okay, Y. What is the equation? Okay, anyone wants to help Nurin? What is the equation?
1/2 U plus V multiply with V T.
Multiply VT. Sekejap. Equation apa tu Y/2. Y/2
1/2.
1/2. Sorry. Okay, 1/2 U plus V T. Okay. Got it. Okay, so saya tak sedar siapa yang cakap tadi tu. Thank you. So 1/2 U plus V. U is 50 sin 30. Do we know our V in this case? Do we know our T yet? Tak tahu kan? So kita tak boleh pakai equation ni lagi. So what equation should we use? SY dah betul. Come on guys.
UT
Apa? Oh,
V
SY
plus
UT
Plus 80.
Okay, let's try that. Okay, so this is 50 sin 30. Okay, kejap. Boleh pakai equation ni, tapi saya malas. Okay. Saya nak buat yang senang. Okay, AT squared. Okay, AT squared is minus 9.81 T squared. Boleh? Minus 9.81 T squared. Come on guys, it's just linear kinematic. Dia cuma apa yang berbeza is just X and Y component. It's the same. You should be confident when using the equation. So 50 sin 30 T plus minus 9.81 T. So kalau saya sebab saya malas, so saya cakap okay, so I know that at the highest point my Vy is equal to 0, right? At the highest point my V is equal to 0 and my Uy is this guy 50 sin 30 minus 9.81 T. So I solve for my T first. So T is equal to 50 sin 30 divided by 9.81. So it's 2.55 seconds, right? 2.55 seconds. So I get the time. And from the time, I can plug it into this equation. Nanti kita buat ni balik I can plug it into this equation. Like I said, it's a two-step, but I don't like to use quadratic equations sebab saya tak suka pakai calculator punya equation ni sebab saya rasa saya akan buat salah. Kalau korang rasa macam cekap, tak apa. You guys go for it. So U is 50 sin 30. My V in this case is 0 because I want to say that this is my final displacement for section 1. This is my final displacement SX, SY. And therefore, this is my V. Lah lukisan pun. Sekejap, saya buat lukis balik. Okay, let's redraw that. So ni besar sikit. Taklah besar sangat pun kan. Besar sikit lagi. Okay. So I want to say this is my V. Y. This is my U. Y. Therefore, if I use the value Vy over here, I am actually finding Sy. And if I use if I use whatever value time over here, I am actually finding the Sx. Like I said to you before, kalau saya cari anything at this dot, Dia semua kena sama. As displacement in the X kena sama, displacement in the Y kena sama. Apa lagi? Time kena sama for this point, time kena sama. So at this point, I want to say, okay, this is my final Vy. So the time that I get is actually the time for here, the time over here. I use Vy equals to 0, therefore I get time at the midpoint because this is where I set V is equal to 0. Kalau saya letak value V over here, Vy kat sini and the value is not 0, whatever it is, minus 20 ke apa, I will get T over here. It will be a different value and the time will be responding to the time taken to reach this point. So dia akan jadi lebih banyak lah. 4 ke 5 ke tak kisahlah. But what I'm trying to say here is if you say that this is your V, your final velocity, the time that you get from solving this equation is the time you reach that point. The time you reach the same point. If you put in V punya value over here, you get the time over here. It corresponds. Tak boleh berbeza Okay, so padam balik benda lah ni. Okay, so if I solve for Sy now, will I get the displacement Sy over here or will I get the displacement over here at the maximum height? Which displacement will I get with 2.55 seconds ni? Will I get the displacement at the end or will I get the displacement at the maximum height? Tengok equation ni. What displacement will I get? Apa dia?
Maximum height.
Maximum height.
Kenapa? Sebab saya pakai V0, V equals to 0, sorry, Vy equals to 0. And I use the time at Vy equals to 0, which corresponds to this point. So when I solve for Sy using these values, I am finding the displacement for the maximum height. Okay, so with that said, I get 50 sine 30, I don't know, 50 sine 30 divided by 2 times 2.55. Okay, so it's 31.88, 31.88. Now kita try pakai equation lagi satu yang saya malas tadi tu, which is I don't have space. Let me try to squeeze it over here lah. So S equals to apa tadi, UT plus 1 over 2 AT squared. Okay, assuming kita tak tahu time lagi kan tadi kan, we wanted to solve for time, but we know what our U is, we know what our A is. Oh wait, we don't know our S yet at that point. So tak boleh pakai jugalah sebenarnya. Okay, so tak boleh pakai sebab tak tahu T. Kita solve for T, but we need to solve for T, we need to know what is S. And we didn't know what S was and we didn't know what T was until I became lazy. Okay, kejap. Ada soalan. Doktor, boleh ke pakai V equals to V squared U squared plus 2AS? Okay, let's try it. I think boleh. So one of you is saying V squared equals to U squared plus 2AS. Okay, so what is the value V that I should use here? What is the value for V? Oh, dah nak masa. Okay, I'm going to speed up. So V, you should use 0. U, Y, kenapa pakai 0? Sebab nak cari maximum height. Therefore, this one is SY. SY over here. Okay, so U is 50 sine 30. Plus 2 minus 9.81 and we solve for S, Sy, dekat maximum point, dekat tempat yang V equals to 0. Okay, I cannot emphasize that enough. Selalunya orang buat mistake kat situ. Sine 30 plus 2 minus 9.81 times with, oh S tak tahu, sorry. So minus 50 sine 30 divided by 2 divided by 9.81. So I get my SY as, oh this is wrong. This is squared, sorry. 50 sine 30 squared. Okay, divided by B squared U squared plus 2AS. Okay, divided by 2 divided by 9.81. So I get 38.86. Lebih kurang lah. Okay, 31.86. Ada difference in decimal points because round off errors, blah blah blah, benda tu lah. Okay, so you get the same answer. So correct, you can use this equation, you get the maximum height. But the trick here is to know that your V is equal to 0 at the maximum height. Okay, I think that's it for today. So I'll see you guys on Friday. Wait, Friday, yeah. Okay, bye guys. Have a great rest of the day. Hari ni kita cram in banyak-banyak, so sorry for that. Kita kena catch up. Okay, bye guys. Take care.
Thank you, Doktor.
Thank you,
Thank you,
Thank you,
Doktor.
doktor.
Thank you, Doctor.
Bye, Doctor. See you soon on Thursday.
Okay, see you soon.
Doktor?
Yep.
My Putra Blast have problem. I cannot sign in the attendance.
Oh, Aizat. Okay, tadi saya dah sign in kan tau. Saya dah tick out punya attendance sebab saya nampak nama awak dah.
Oh. Thank you.
Awak dah contact siapa-siapa ke untuk Putra Blast punya problem ni?
Belum.
Ada okay, tak apalah. Nanti saya bagi tahu Encik Fadzil. Okay. Thanks for letting me know. Bye-bye.
Thank you, Doktor.
Welcome. Bye-bye.